All right, so here's why I want you to make a new note card. Because yesterday we learned the last step, right? Or I shouldn't say the last step, the last missing step. Okay? So now we've got all 8 steps ready to go. Okay? So we can reorganize our note card with all 8 steps. We have them on there. We might actually have the steps on there that we want. Okay? Not just some random thoughts. Okay? We want, yeah, whatever. Yeah, whatever. Okay? All right? So, there's our function. Okay? So, step 0 is simplify the rational function. On your note card.
On a new note card or on an old note card?
Oh my God, Joey! Stop.
Joey, just stop talking.
Really?
Just stop talking, Joey. Okay? Alright? So, we're going to simplify the rational function. Okay? What are we looking for? Common factors. Okay? We're gonna simplify and we're going to get rid of common factors. Okay. Sometimes we can do step 0, sometimes we can't. Right? Kind of like in all of these. Sometimes we can do them, sometimes we can't. Okay? After that, what's step number 1?
Find the domain and the vertical asymptote.
Find the domain and the vertical asymptotes. How do I go about finding the domain and the vertical asymptotes? Actually, before we do that, I'm going to put a little star here, and I'm going to say, see step 5. If there is one. Okay? Because remember we were going to get back to that. Okay? So, how do I go about finding any vertical asymptotes?
How do I step 6?
What?
Set the bottom equals
That is
0.
not an x equals 0. India?
Bottom equals 0.
Set the denominator equal to 0. Okay? So, we want to set q of x equal to 0. Okay? Our denominator equals 0. Then, that's going to give us our domain, correct? Right? And then our vertical asymptotes are what?
The x can't be out of the domain.
X equals the, what of the domain? The restrictions in the domain. How many vertical asymptotes can there be?
As many as the degree, the biggest degree.
Of what? There's
The
multiple.
function of the denominator.
Many as the denominator, right? Okay. So can there be 0 vertical asymptotes?
Yes.
Yeah. Can there be 1 vertical
Yep.
asymptote? Can there be multiple
Yep.
vertical asymptotes? Okay. So we can have 0, 1, or multiple. After we do that, what do we do next? Now we're looking at horizontal asymptotes. do I do there? No.
And behavior.
No.
No, whatever.
I compare degrees, right? What are my three possible outcomes?
None.
None.
0. Or A over B.
What are my three
Top-
possible
if top-
outcomes?
If top is greater than bottom, no horizontal aspect.
If the top is greater than the bottom, then there's none. If the top is
Okay,
lower
stop.
than the bottom.
Okay. Matt?
What?
She said top bigger than bottom, there's none.
If top is less than bottom, is y equals 0.
Okay, so if top is less than bottom, our horizontal asymptote is y equals 0. Whoever was saying 0 and whoever was saying A over B, I don't know what you're talking about. Okay? Because we're talking horizontal asymptotes, so it's y equals that. Okay? What's the other one? Top equals bottom.
Horizontal S equals Y equals A over B.
And where do you get A and where do you get B from? Lead coefficients. A is the lead coefficient of the top, and B is the lead coefficient of the bottom. Okay? And then that, back to your first one, and there's a reason I put it last. Top is greater than the bottom. What's our horizontal asymptote? None.
Unless step 6 is different.
Y.
But
If step 6 is different.
what's
There's always going to be one, but
if they differ by one?
One.
Okay, that's the kicker. So there's an asterisk here because if they differ by one on this last one, I have to do step number 6.
What difference by one?
If the top is bigger by 1, I have to do step 6.
Bottom is bigger.
If they agree.
The bottom is bigger by 1, I'm not even over there. I'm over here in top is less than bottom.
The degree.
If the degree of the top is bigger by 1, I have to do step 6. Okay? How many horizontal asymptotes can there be?
1 or 0.
1 or none. Okay? Step 3. Find the y-intercept.
By setting x equal to 0.
So I'm really finding
F is 0.
f of 0. So then my y-intercept is
0 common number.
0 comma f of 0, right? How many y-intercepts can there be?
1.
1 or none, right?
Find x intercept.
What was I meant? Find the x-intercepts is the next one? What do I do to find the x-intercepts?
Set the numerator equal to 0.
No.
Set the whole top, the numerator equal to 0.
Set the numerator. That's where the numerator equals 0. And then we solve that. Okay. And then this is going to be some number, comma 0, right? How many x-intercepts can there be?
Multiple. Or not.
0, 1, or multiple, right? Because there could be 3, there could be 4. Then what do we do?
Find the hole.
Find the holes next. Okay? So this was from step 0, correct? So if there was a common factor, in step 0, what do I do then?
And you set it equal to 0.
Set what equal to 0?
The
The common factor.
and then you take that number and plug it into the function to find the y.
So then we find, so if the common factor is equal to 0, then it would be a common 0, right? Okay, that's just learning back our algebra 2. So I find f of our common 0, and then the whole is at the point, the common 0, comma, f of the common 0. How many holes can there be?
As many. Yeah.
So how many can there be?
0,
0, 1,
1,
or multiple?
Find slant answer.
Find slant asymptote. So this is when what?
Top is bigger than bottom.
But there's this slant asymptote, there's no horizontal asymptote, right?
Correct. Okay. So this is if the top degree is bigger by 1, then there's a slant asymptote. What do I do to find the slant asymptote?
divide.
Divide the fraction out?
Yep.
This should have all been. What color was this? This was brown.
You get the 8. Why should that all be brown?
What?
Why do you want that brown?
Because that's the color that I use
This?
for slant asymptotes. I don't know if you've noticed, but all of your notes have been color coded.
No,
This
I-
entire chapter.
I knew we have it, just didn't know.
Okay?
I didn't know this stuff.
Then what do we do?
Plug and shift.
Drop the remainder first.
Sorry.
I remember.
And then our slant asymptote is y equals the linear leftovers, right?
Will the slope always be 1?
No.
No, I had to fight with you.
Yeah.
I lost.
He did. How many slant asymptotes can there be?
1.
0 or 1.
0 or 1. Yep.
Ones will always win in a fight that involves math. Just saying. Minus bracelet.
And what's our last step?
Find the
Graph.
point.
Find other points, right?
You
So
got a
we
graph.
make the graph by finding any additional points to complete the graph. Okay? So now you've got a brand spanking new note card with all 8 steps on it. You're ready to go. We're all set for next Tuesday's test. Yes, ma'am.
So I have some questions about behavior. So
Let's get to a graph first, and then we'll talk about it. Okay?
no, it's just a quick one.
Okay.
So for the M behavior, it's always this x goes to positive or negative infinity. Is it always 0?
No.
No.
Then f of x goes to 0 is it the
It's whatever-
Horizontal
it's-
asymptote.
It's the
vertical asymptote is
It's the horizontal.
horizontal.
And
Yep. And behavior goes to the horizontal
And
asymptote.
asymptote behavior goes vertical.
The vertical asymptote behavior, yes, goes to the infinity.
I have a question. Will we do a
Asymptotal is
vertical?
then as x goes to the vertical asymptote
From both
x
sides.
goes to positive or negative infinity.
Yep.
Yeah.
Will we graph a function that has like 3 vertical asymptotes or 4 in it?
Never know.
In this unit?
You never know.
Friends, I want to know, like,
Okay,
I want to test this out.
go for it. Here we go.
Could you do it? Just have it 3x plus 9 proof.
You can.
Are you going to get
Because you're not going to
simple?
simplify anything else.
Why? What's step 0?
Simplify.
Simplify.
What would that?
Okay.
Can't
So if you
simplify
can't-
anything else.
You can't go to step 1 without doing step 0 first. You know what I mean?
So
So
I did the whole problem wrong.
You did it though. What's the difference? I think I did the horizontal asymptote wrong, so I.
Yeah, I don't know. I'm really confused.
Yeah, that's right. So 5. That's what I got. Horizontal asymptote. I'm not going to use it.
No, I got to that. So I can change it.
It will though.
Oh,
Because- oh no, it won't. Yeah, it won't. What am I thinking? That's the problem. So far, I'm still with you. Yeah, I got it. Y-intercept.
why do you use the other function?
because there's only 2 x's that I have to put into it, as opposed to 3. So at negative 9/4, that's negative 2.25. You should be.
So an x-intercept.
Yeah, but how do you put it there if there's a thing there?
You can cross the horizontal asymptote as long as you're not at the infinities.
because of what he just said.
Yes, you did. You said it great too.
Doesn't make any sense.
Okay?
It does though.
But
You can't cross the horizontal asymptote unless you're at the infinity.
No.
When you're at the infinities, you can't cross the horizontal asymptote.
That I like better.
You can't cross.
anywhere in the middle, anywhere between negative infinity and positive infinity, you can cross. You can cross it 4 times if you want.
6 times, 8 times.
Okay.
10 times.
But at the infinities, you can't cross it. That's what it approaches as it's going to the infinities. Hole?
There are none.
Slant asymptote?
I got it. That hurts.
So I got some math to do here now, right?
A lot of graphing.
So my function was again
So you would use
3x plus 9 over x squared minus 4.
So why do you simplify that? If you're not going to use a new function, why do you simplify?
So I know I didn't have to factor anything out. I didn't tell you to erase anything. Okay? So negative 3 I'm okay with, but I cross at negative 3, so I'm going to try negative 2.5. And I'm just going to see at negative 2.5, I'm going to see if it's above or below. That's all I'm looking for, is if it's above or below. Okay? So if I put negative 2.5 times 3, that's negative 7.5. Plus 9 is positive 1.5. Negative 2.5 squared is 6.25. Minus 4 is positive 2.5. Positive 1.5 divided by positive 2.5 is 0.6, and that is positive. So I'm above, so as I come closer and closer to that asymptote, I'm going to be shooting up.
That vertical asymptote.
Okay? All right? Now, let's check negative 10. If I put negative 10 in there, I get negative 30 plus 9, which is negative 21, over positive 96. That's going to be a negative number very close to negative 0.2. So my function on this side of the asymptote, of my vertical asymptote, is underneath but crosses over and turns upward.
How are you doing that? Still behavior.
It would be, and this side it would be as x approaches negative 2 from the left. Half of x goes to positive infinity. And behavior would be as x goes to negative infinity, my function approaches 0 from below. Even though I crossed it, now I'm below.
So it only matters where you are at the infinity.
Infinities are important.
Now, positive 1 and negative 1. So that's going to be negative 3 plus 9 is 6. 1 minus 4 is negative 3. That gives me negative 2. So it appears that I have an upward swing there. Agreed? Okay, let's try one just to make sure in between negative 1 and negative 2. So let's go with negative 1.5. Negative 1.5 times 3 is negative 4.5, plus 9 is positive 4.5. Negative 1.5 squared is 2.25, minus 4 is negative 1.75. So if somebody that has a calculator could give me some assistance, positive 4.5 divided by negative 1.75. Negative 2.6. Okay, so that is coming down then again. Okay? So my function, it's kind of goofy there in the middle, okay? Because it's not cubic in there. It's actually a funky type parabola. Okay? So then let's try positive 1. If I put positive 1 in there, I get 12 over negative 3, which is negative 4. 1, 2, 3, and 4. So my function here on the inside looks like that. Now I've got to go here, and so let's go 3, 4, and 10. If I put 3 into my function, I get 18 over 5. If I put 4 into my function, I get 21 over 12. If I put 10 into my function, I get 39 over 96.
How do you do that in your head so fast?
You grew up in
3
January
times
without
3
calculating.
times 3 is 9, plus 9 is
Yeah, I
18.
know, but you do it in like 2 seconds. Like just 5 points takes me like over 5 minutes.
I haven't plotted any points yet.
Yeah, but I know, but you
Oh.
find the freaking fractions so fast. It takes me like forever.
He grew up in
I
a
could-
generation
He grew up in a
without
generation
calculators.
without a calculator.
I grew up in a
Oh
generation
my
without a
God,
calculator.
That's the worst part about this. It always takes me so long.
I used the calculator that's stuck in between my ears.
You have one of them. Is it smarter than
So,
smarter than
And then here now, 18 divided by 5 is not quite 4. 1, 2, 3, and so I'm right there. 21 divided by 12 is not quite 2. 39 divided by 96 is almost a third. So this one on this side then is
I'm gonna get my turns.
not very often.
Never question them. See how
I did like the
hard
middle and the right side perfect, but then the left side, I messed up.
Yeah.
Because this was the first one where it crossed your ass for you.
No, we had a
No,
couple.
didn't we have one in the test?
We had a couple where they crossed it.
Yeah, have we had one?
Yeah.
Well,
They
not
crossed
on-
they
in
crossed
the middle, yeah.
Between the
In
verticals.
between the verticals, yeah. This was the one that crossed on the outside
Yeah.
of the vertical.
I thought we had
I was
one.
messing everybody up.
How did it go from the bottom to the top?
We just tried some more points.
So, kind of partial.
Just can't cross over at infinities. So like at negative infinity, it's not going to cross back over to the positive side.
It can
Right,
only
you go below and up and below. You can go under and over the horizontal.
Now let's question for you. Could it cross the like at 1 million? Could it cross back over the positive side? You wouldn't have known us.
Well, if you put it in a really big number,
Or
right?
negative.
Remember how we did end behavior at the start of the chapter?
Yeah.
You put in a really big number, okay? So you're going to have 3 times that really big number plus 9, so that's going to be a positive number, right? Okay? And then you're going to have
Really big number.
really big number,
Really
right?
big
I'm sorry, really big negative number.
Yeah.
Why
with
is it giving me
positive.
negative on
Negative, because we're going this way. Okay, so a really big negative number, so you're going to have a negative huge number on top. But you're going to have a positive huge number on the bottom, so it's going to stable.
Why would you have a positive on the...
Because you square a negative, it's positive.
Yeah, I figured
Okay.
that out.
And you subtract 4, and you're talking at infinity, you're taking 1 grain of sand off of the beach. Okay?
That's possible.
To take 1 grain of sand off the beach?
Yeah.
Yes.
Just one.
Okay?
You need a.
Right. Do this one.
That was
Throw it too. Make it loud.
Put a hand on it.
Which function was the common factor? Your last one or the original one?
New one.
This one. Divided by x minus 3. And then x plus 1. And then cancel. so smart ones.
I think you would make the difference. Remember the discussion we had Friday about your homework?
Homework does not matter.
I'll let them fight that battle.
Okay.
Like,
Yes.
Yep.
So my domain is.
all real. X cannot equal -3.
How about positive 3?
3, yeah, where am I going?
To California, apparently.
Ugh. I'm taking a long way to Florida, guys. Hold on. Give me a minute here.
Yeah, you read it.
There's multiple ways you can take. I just decided.
Degree of the top, Carson.
One.
Degree of the bottom.
One.
So those are the same, right?
Right. 0.
No.
Y equals 2.
Y equals 2 is our horizontal asymptote.
Because that's the
The
biggest.
lead coefficient on the top is 2.
So what's the biggest variable?
Is the degree, yes.
So like I asked them if it was x plus x squared, you take the x squared because it has a bigger degree.
How am I messing this up once? I don't know.
Right? Did I say that right?
So India, on this one now, because our horizontal asymptote is 2, our end behaviors are going to be approaching 2.
Okay, good. 'Cause that's
Not zero.
what it up.
Okay?
Now we go on to the y-intercept.
Zero comma negative 2/3 as a y-intercept.
It's 1.
The x-intercept is something times 0.
So what happens is 2 again?
Just divided on both sides. I get an x-intercept of negative 1 comma 0. Do we have a hole?
No.
No. Yeah, we do.
Yes, we do, because we factored out an x plus 1, correct?
Yeah.
Okay, so that means we have a hole at x equals negative 1. What's the value of my function at x equals negative 1?
0.
0, right?
Yeah.
So I have a hole
Zero.
at negative 1 comma 0. So what happens to my x-intercept?
You would make it a hollow inside.
It would make it a
hole.
none. I don't have an x-intercept.
So if you have a hole at the same place as x-intercept,
The hole trumps everything, yes.
The whole wins.
But it's still okay. Never mind.
I surrender.
But so then this becomes a hole there instead of an x-intercept. Okay?
So if this problem was on our test and we wrote -1 comma 0 for the x-intercept, it'd be marked wrong.
Correct.
Because there is no x-intercept.
The hole is everything.
Okay?
And there is no slant S3.
So I've got 2 points on that side. Let's go one closer, so let's go 2 into my function. 2 plus 1 is 3, times 2 is 6, over, so that's negative 6.
Well, when you
1,
have to,
2, 3, 4, 5, and 6.
when
Let's go negative 10. Hold on, man, I want to get this done. Negative 9, so that's negative 18 over negative 13. So that's up here. And so then this side goes like this, comes down, stops, comes down, goes down. This side, let's go 4. That's going to give me 10. Let's go 5. That's going to give me 6. 2, 3, 4, 5, and 6. Let's go 10. That's going to give me 22 over 7, which is a little more than 3. So then this side looks like that. Okay, with me? So here then, India, answer your earlier question. As x approaches positive infinity, my function approaches 2 from above.
Yep.
As x approaches negative infinity, my function approaches 2 from below.
We only have one graph left in this unit, don't we?
Alright? Couple of quick things. 1, there is a formative tomorrow, yes. 2, blue packet is due next week Tuesday, a week from today. 3, test is next week Tuesday, a week from today. 4, class is over with.